Okay, for this afternoon, we'll discuss on semiconductor diodes. So supposed to be this is our main resource or our textbook, Electronic Devices by the STAD. So we'll go over these slides in a while, but mas better tong isang slide nga akong na-referan, no? Uh, mas ma-visualize na to ang ang mga concepts if you'll use this one. So before that, last meeting, we've introduced the concept of the electronic system. So sa tanan nato of all the systems that we're going to encounter not only in our daily lives, not only in the study of electronics engineering or pursuing our degree ECE, but also sa tanan types of electronic systems that we're going to undergo or analyze, we're going to use that construct, no, or that model, the systems approach. So if we're going to use that approach, it doesn't matter for us. It doesn't matter for us if whatever things are made up ang katong system. Basta kay the things that is of concern to us are only the input and the output. Okay? So that is if we're going to study a particular electronic system. Although the system's point of view or system's approach to studying electronic systems is also useful to studying some other types of engineered systems or man-made systems, like whether electrical system ba na siya or mechanical system, useful gyapon to siya. But what distinguishes an an electronic system to that of other systems are the electronic devices that make up the said electronic system. Okay? So in simple terms, ang electronic devices na included, okay? The electronic devices na included, whether isa na siya buok na electronic device, that's what make all the difference, no, sa isa ka electronic system. If it is an electrical system, gani, no, if it is a purely electrical system composed of sources, voltage source, current source, or resistors, capacitors, and inductors, balag kung saan ka-complex o numerous nga amounts of resistors, inductors, and capacitors, basta na ay naka-include nga masking isa lang kabuok nga discrete electronic system, that is already an electronic. If na naka-include na isa ka electronic na device, that already is an electronic system. No? So the question that we should be asking is not really what makes an electrical system different from electronic system just because sa katong particular electronic device, but what makes an electronic device electronic. Okay? So how does the concept of electronics work? Okay, why do electronic devices work the way that they do? How do they work particularly? Because electrical systems or electrical devices such as resistors and light bulbs, simple naman ang concept. You just plug it in and paano siya, no? Na current mag-flow, meaning the electrons of the conductors will flow, and then that's it. Okay, yan na ang electrical na devices. If applyan na to voltage, if we apply voltage to an electrical device, that will cause the electrons of the conductor inside that electrical device to flow. Hence, nag-work na, no? Nag-work na ang atong electrical device. And because of the flow of electrons, it's either...
Sir, sir.
Yeah, isa man.
Ang slide, sir ba, nga, percent imo sir kay
Oo,
nag-next? Okay.
wala pa ako nag-next.
Ay, okay. Sige, sir.
Sige. Paano pa rin siya, marag, introductory pa rin siya ng mga words.
Okay, sir. Thank you,
So,
sir.
okay, thank you, Ai. So, kato, if an electrical device does work, it's either it will dissipate energy in the form of light or heat. Okay? If light, example lang na light bulb, di ba? Or incandescent bulb. If normal nga resistor, then it will dissipate energy in the form of heat. Okay, mo init man ang resistor. I think na even if dili resistor, no, even if plain nga wire, basta substantial amount of electricity atong gikuan, bantay na to nga mo init siya, so nag-dissipate siya to of energy. Yan na. So but that is for electrical devices. Okay? Applyan og voltage, mag-flow ang electrons sa conductor, thereby producing current. But what about for electronic devices? Now, how does electronic devices work, or why do they work in the first place? So, the particle in question when we study electronic device is, of course, even if dili electronics, no, even if electrical, mag-start man kita sa physical na model of the atom. Okay, the atom. So we'll be using the Bohr's model of the atom. So what are the components of an atom, man? Diba, we have three components of an atom. Without going deeper sa chemistry, so we don't need to conjure up our previous knowledge on chemistry, but the three components of an atom, as we all know, is the proton, the nucleus, and the electrons. And the nucleus is composed of the neutron and the proton, right? The proton is the positively charged particle of the nucleus. The neutron is the electrically neutral na particle of the nucleus. And the more mobile particle and also the negatively charged particle of the atom that is orbiting the nucleus is what we call the electron. So in the study of how electronic devices and electronic materials work, or semiconductor materials, focus lang ta sa electron. No? So pwede na nato iwala sa itong una-una si nucleus or si proton and si neutron. Okay? So again wala na si proton sa picture. We'll only focus on the electrons. And dili gani tanan electron atong i-focus. Actually, we'll only focus pagid gani sa valence electrons. You know, the electrons occupying the outermost shell of the atom. Okay? So not only are we focusing on electrons, but only on valence electrons, the electrons on the outermost shell. So, okay, as for conductors, say for example, this is an example of a conductor. It's 29. Element 29. Base a slide. Copper. Copper? Copper, sakto. So this is a Bohr's model of a copper na atom. Okay? It has 29 electron count, meaning na siya 29 electrons. But how many electrons are in the outermost shell of the copper atom? Even if wala taga-dumdum, makita nato sa slide that it has only one. No? It has only one electron in the outermost shell. So, isa lang iyahang valence electron. So, copper is an example of an excellent conductor. So, ang common attribute or common characteristic of conductors is that it has very few valence electrons from 1 to 2. Okay, 1 to 2 valence electrons, conductors. Okay, sometimes, most of the time, we define conductors as those that are good conductors of electricity, right? Or heat and electricity. But in an atomic point of view, we shall consider conductors as those elements that has very few valence electrons, meaning nara sa mga 1 to 2. Of course, opposite ang insulators. Wala man dire example sa element kanay element sa isa ka insulator, but insulators have valence electrons ranging from 7 to 8, no? Mga daghan sila og valence electrons. So yeah, what about in between? So we not only have two types of materials in terms of conductivity. Not only do we have conductors and insulators, but we also have what we call semiconductors or semiconductors. Semiconductors has with respect to valence electrons has four numbers of valence electrons. Silicon is one of the best examples of semiconductors. It has also 4 valence electrons. If there are some of you who has already browsed or nakabasa na daan sa atong textbook in chapter 1, there's also another element together with semiconductor that is also considered. There's also another element together with silicon that is also a semiconductor. Do you have any idea? What is that other element na semiconductor pod because it has 4 valence electrons? Okay, thank you, Angelo. Germanium, right? Germanium is also a semiconductor because it has 4 valence electrons in its outermost shell. So unlike metal, silicons form strong covalent bond with its neighbors. Okay, kaya na siya. So we have two types of semiconductor materials. We have the intrinsic semiconductor and the extrinsic, yung opposite, extrinsic semiconductor. So what's the difference between the two? Para dili tama, just to put it plainly, what we mean when we say intrinsic silicon is if ang silicon is pure siya, no? Pure, intrinsic na nga semiconductor. Yan na lang, okay? That's how simple we could put it. Ang intrinsic semiconductor is pure. Meaning, if pure siya nga silicon, meaning dili bitaw compound. Kung pure siya nga silicon or pure siya nga germanium, intrinsic siya nga semiconductor. And actually, intrinsic semiconductors in normal conditions or in normal situations are more likely to behave as insulators. Okay? So take note of that, ha. Usay ang akong mga additional nga ipangingon. It might be nga wala sa slide. But yeah, intrinsic semiconductors, even if wala sa slide, no, na for sure na siya sa mga references nato or sa book, okay? Because yes, hindi mo not necessarily ibasa per word yun ang slide. That would be time consuming. Just take note of the added information na akong ipangingon, okay? So, if pure siya na silicon or pure na germanium, it's an intrinsic semiconductor. So, unsa ang extrinsic? Ang opposite. So, dili siya pure. So, what makes or how could we make an unpure semiconductor or an unpure silicon or an extrinsic semiconductor. If we add impurities, so nabay this slide. Dala, okay? Adding impurities. Certain impurities will change the conductivity of silicon. An impurity such as antimony has an electron that is not part of the bonding electron, so it's free. Okay. So we have two types of impurities. Okay, balik to dire ha. Only then, if we add impurities, could we make an extrinsic silicon. Okay. So what's the process of the process na i-undergo sa silicon or germanium, or the process that na i-undergo sa intrinsic semiconductor for it to become an extrinsic semiconductor is the process that we call doping. Okay, doping. I'm just not sure if nabasa slide. Yeah, i-take note na lang ninyo. DOPING, doping. Doping is the process of adding impurities. Okay, adding impurities to intrinsic semiconductor. So there are two types of impurity atoms. Okay, we have two types of impurity atoms. Or impurity atoms. Kay element man ato i-add sa silicon, no? Some other element that we add to silicon to make it an extrinsic material. Speaking of extrinsic material, I think it's appropriate na ako nang i-introduce that we have two types of extrinsic semiconductors. Okay? We have the P-type semiconductor and the N-type semiconductor. Okay? Ano lang. Both P-type material and N-type material have energy levels that are different than intrinsic silicon. Pikas daw ko nga slide, bro. Kasi mas kondiri sa atong usual nga slide. No? Yapon helpful. Sometimes di kayo helpful ang slide. Aha. Ano na lang, no? Remember lang ni. Before I go further, no? Recap lang. Silicon, how many valence electrons does silicon have? Pila ka valence electrons?
4, sir.
4, very good. Okay, thank you, Nico. Silicon and even germanium has 4 valence electrons. So if we have, imagine na lang niya, kani. If ang atong silicon has neighboring silicons also, because when we speak of semiconductor material, of course, we are not speaking of only one element. Daghan man gina sila, and katapad-tapad man, di ba? The semiconductor material that's made of silicon is most definitely in a crystal nga form, no? So na-crystalline na siya nga formation, meaning nagtapad-tapad na sila. If nakadumdum mo sa chemistry, pila ka electrons gani dapat sa outermost shell para sa mahimo siya stable?
8, sir.
Okay, thank you, Nico. So we need 8 electrons. Okay, 8 electrons for us to have a stable na bond. Yeah, bond ang proper din ang term. 8 valence electrons sa outermost shell. So meaning, if kani nga silicon, mo na siya sa tunga, if na siya'y tapad nga silicon sa iyahang right, and na siya'y tapad nga silicon sa iyang left, and dapat napod sa taas, no? If napod ni siya'y silicon sa bottom and sa top nga part, so we have a covalent bond na si silicon sa middle is supposed to be upat man ikabok iyang kuan, di ba? Don't mind na lang to or kanina lang. I think better ni siya. Just try to imagine silicon ni siyang nasa tunga. Antimo ni manggod ni pero just try to imagine silicon ni nasa tunga, di ba? So the silicon has four valence electrons just like this one, no? Na siya upat. But tungod kay na siya four other neighboring silicons sa iyahang bottom and top and right and left nga part, nagka-pair, no? Di ba? Nagka-pair na dayon ang mga electrons. Instead nga na siya'y only 4 valence electrons, silicon sa middle, silicon in question nato karon, ang iyang taas nga part, as if virtually, duha na kabuok. Kay gi-share man, di ba? Gi-share ni silicon sa taas, ang iyang isa ka electron kay silicon sa middle. In the same way nga gi-share sa mga silicon atoms sa bottom part, sa left part, ug sa right part, ilahang mga valence electrons pod kay silicon sa middle. So si silicon sa middle, naa na siya 8, no? 8 nga valence electrons virtually sa iyang outermost shell. Kay gipang share man sa iyang mga neighboring silicons ang ilahang mga kuan, ilahang mga valence electrons also. So that's why an intrinsic silicon behaves much like an insulator because stable man iyang stable naman iyang bonding. Even although covalent lang siya, and we all know covalent is a weak type of bond, but still stable na kay pares naman. So that's why an intrinsic semiconductor acts more like an insulator. Okay? Now, again, what's the process of adding impurities to intrinsic for it to become extrinsic? Doping. So in this slide, si silicon gidope nato, no? Gi-add nato og impurity atom in the form of the antimony. And antimony has how much valence electrons? It has 5. Sige lang, ayun na lang i-remember kay basig man. Di mo kadumdum pa. Antimony has 5 valence electrons. So, even if magamit ang simple nga arithmetic, if silicon has 4, okay, if silicon has 4 valence electrons, asa man gikan ng 4, gikan sa upat ka silicon around the antimony atom, and antimony has 5. So 5 plus 4, that's 9, di ba? Right? 9, 5 plus 4, 9. So 8 lang man ang kinahanglan para ma-stable ang bond. So tungod kay na ay isa ka free electron, no? Wait. Tungod na ay isa ka free electron, nga gikan kay antimony, kay 5 man yang valence electrons, ito ang maband sa 4 other neighboring silicon is only ang 4 sa iyahang 5 valence electrons. So si antimony has 1 extra electron right here, no, nasa top part, free electron. So when we speak of semiconductor material, again, dili naman siya isa ka antimony atom. It has millions, gihapon, no? Millions of antimony atoms. So if it has millions of antimony atoms, ang effect ana, that could produce millions pod of free electrons. Sa plan nyo so far, is there any questions before I go further?
Sir, unsa gayt tong process nga doping, sir?
Ang process of doping is just the addition of impurity atoms. In this case, again, if we begin with silicon lang, no? Silicon material, semiconductor material, pure, okay? So, doping is the name of the process sa pag-add na to og impurity atom. In this case, antimony. Nga na lang why. Sabtan?
Yes, sir.
Okay. So, kaniha, originally we have silicon atoms nga bonded with each other. But now, gidope na to ang silicon, gidungagan or gi-add og antimony. But because antimony has 5 valence electrons, isa ka-unbonded nga electron for every antimony atom, right? Makuha ninyo anong isa nga sobra.
Yes, sir.
Okay, so I hope Kia speaks for all of you. Yeah po na. Again, if there are questions, don't hesitate lang ha to. Pwede lang mo raise inyong hand by clicking on the button sa Google Meet or i-on inyong mic, then sir, na ko question, yan na lang. Pwede lang ko niyo i-cut anytime if ever gina mo question. Okay.
Pero sir, unsay kay pagsuot mo sa technical definition, unsay purpose sa doping, sir?
Doping ko para mahimong extrinsic ang intrinsic. Yan na lang. We could think of it that way. Ang ano man, yun sa pagsulat technically sa doping.
Wala, sir, kay ganotes ko, sir.
Okay.
Matanar ako.
So, kung technical yun nga definition sa doping, makita pa na to ha. Doping. Yeah, malagmawala gito kay. Intrinsic materials are those semiconductors that have low level of impurities or no impurities at all, meaning pure, whereas extrinsic materials are semiconductors that has been exposed to a doping process. So if we could simply define doping, it's just the addition of impurity atoms to intrinsic semiconductors for it to become extrinsic. No? So ang atong doping material here or doping atom is the antimony, which has 5 valence electrons. But because 4 lang ang maximum na pwede ma-bond sa neighboring silicon atoms niya, so si antimony na isa kasobra, di ba? Na siya isa kasobra nga electron floating around. And if there are millions of numbers of antimony atoms, it follows that we also have millions of free, or basin nga ni billions of free antimony. I mean, billions of free electrons floating around. Okay. So ang effect ani or ang output is an N-type na material. Okay? Kung basahon na lang ha, certain impurities will change the conductivity of silicon. An impurity such as antimony has an electron that is not part of the bonding electron, so it is free. And isa naman sa kabuok. This creates an N-type material or an N material. Okay? So, N, because somehow it makes the intrinsic material more negative because of the presence of free electrons. Mukha ninyo? Ginganlan siya as N-type material because it is more negative due to the presence of free electrons. So another type of extrinsic material is the P-type material. Okay, P-type. So what are examples of elements or impurities that if we add to silicon will produce P-type extrinsic material? We have boron, gallium, and indium. So let's say, for example, boron. Okay? Unlike antimony, which has 5 valence electrons, boron has 3 valence electrons. So, 3. Okay? Ang neighboring silicon atoms ni boron could only share 4 of their valence electrons. All right, 4. So if they could only share 4 of their valence electrons and boron has only 3 valence electrons, so kulang, di ba? 4 plus 3 equals 7. 8 man ang kinanglan para stable. So, because 7 lang na ay lacking of electron, dire, that we call a hole. Okay? Hole siya, not in a sense nga nabangagan jud ang material, but hole siya because of the need to have an electron fill it up. Okay? So, we should not think of a hole as a particle, okay? Dili siya particle the same sa electron or dili siya particle the same sa neutron or proton. Hole siya because of the lack of an electron of silicon supposed to be, okay? Because boron only has 3 valence electrons and ang mga neighboring silicons niya could only offer a total of 4 valence electrons gikan sa ilang own valence shells or outermost shells. So natay kulang, no? Nagkulang ta og electron which produce a hole. Hence the name p-type material. Okay? So that it doesn't mean nga p-type material siya, it is positively charged. No. Okay? So mara siya somehow isa yun sa mga misconceptions, no? That just because p-type materials has holes, malalugar siya o proton. No, it's not like the proton, for which the proton has an actual positively charged, a positive na charge, but p-type material siya because it's mas lesser nga iyang pagka-negative kaysa sa intrinsic or even sa n-type material because of the presence of holes. Because of the lacking of electrons, it's much more positive compared to the intrinsic. Kuha ninyo? Is it understandable or is something confusing you?
So, sir, we just designate the P-type junction. Murag ma-associate lang siya as positive because relative to N-type, sir, dili kay siya nga naka negative.
Yes, sakto Nick. Ayan na.
Okay, sir, thank you, sir, na-clarify. No?
Okay, so more positive lang siya because of the absence of electrons. That's why p-type atong gingan lang sa iyaha, okay? Dili siya positively charged, the same sa proton. No? Nga na lang. So, recap, okay? Quick na recap. We have 3 types of materials: conductors, insulators, and semiconductors. Pure semiconductors do not necessarily conduct electrons. No? So, ang pure semiconductors are silicon and germanium. They are intrinsic. For it to become extrinsic, we need to subject it to a process called doping. So, i-add na to siya or we add impurity atoms to it like antimony and boron. And depende kung usa nga type nga impurity material atong gi-add. Kung antimony, pentavalent man siya or 5 naman siya 5 na valence electrons. Kung boron ay 3. So depende sa impurity atoms, after undergoing a process of doping, ang atong intrinsic semiconductor would become an extrinsic semiconductor. And extrinsic semiconductors will be classified as p-type and n-type. So, yan na lang. So, ano dahil mo go from here? What could we produce after having p-type or n-type material? So, by themselves, wala na gyapon, no? Technically, p-type materials and n-type materials are just that if we do not do something about it. So, only if we stick together those two types of materials, the P-type and N-type, that we could create something interesting. Okay? So, here comes in the PN junction. A P and an N material together form a PN junction. So, when the junction is formed, conduction electrons move to the P region and fall into the holes. Filling a hole makes negative ion, so on and so forth. So, yan may tabo, no? So, this is the P-type material, okay? P region. It has full of holes, right? It has full of holes. Ang N-type material is full of free electrons roaming about, okay? So if ato siya i-physically stick together, I think yan na lagi na, ipagtapad daw silang duha, na ma-form nga marag intermediate na region that we call the depletion region. No? In this region, nag-transfer ang mga particles, okay? I think it's appropriate nga tagano to designation ng mga kaninga mga particles. Okay? So we have two types of particles here that we call the majority carriers and minority carriers. Okay? So ang majority carrier is the amount of free material, free elements that is present sa kanang type of material. For example, the N-type material. The N-type material has a majority carrier of electrons. Okay, mas dagan man yung electrons kaysa sa holes. Whereas, the P-type material has a majority carrier of holes. So, yung minority carrier are electrons. The same gyapon sa N-type material. Yung minority carrier are holes. No? So, nagya po yung holes. Di ba nato ma-predict yun ang behavior sa atoms at the atomic level. Scientists have discovered na nagya po yung mga ma-produce nga holes. Okay? So, nagya po yung mga holes present even sa N region. Okay? Gamay lang ka isla. That's why we call them minority carriers. So, inyang majority carriers are electrons. In the same way, sa P-type material, nagya po yung mga produce ng mga free electrons, no, nga wala nasulod sa mga holes. That's why, again, we call them minority carriers sa P-type material, ang electrons. So, ang majority carrier sa P-type material, kaya ang holes. So, speaking of majority carriers, ang depletion region is the filling up of majority carriers, no, sa edge sa atong P-type and N-type material. So, nagkuhan sila, no? There's an exchange in this region of majority carriers. So, ang mga holes na naa sa P region is nanga-fill up og mga electrons sa N region. Hence, the depletion region. The depletion of carriers. So, the depletion, deplete meaning nawala, di ba? Walay presence. So, the depletion region is the depletion of majority carriers. Anong nangawala man ng majority carriers sa kaninga region? Because freely tabok-tabok sila on their own. So, silang excess nga electrons ni N material is nitabok para ma-fill in ang holes sa P region, sa P-type material. And nag-form sila tanan dito sa depletion region, no? Nagtipok sila tanan dito. So, because of the presence of the depletion region, electrically speaking, naay na-generate nga voltage level, no? Or physically, or in terms of sa physics, ang iyang proper nga term is potential barrier, no? Barrier potential, I mean. Or kung sa ato, pwede na ito siya naon nga naay voltage dire, no? Naay voltage barrier nga na-form. Tungod sa the joining of the P-type and N-type material. Pwede na ito huna-huna na sa ingani. because of the presence of the filled up P-type and N-type materials sa depletion region, no? Because of the presence of those filled up majority carriers. From physics, we know na this is a recipe for an electrical field. Okay, electric field. Kanang field in between sa capacitors. Okay, so naman tayo mga positive layer sa one side and negative sa other side. So because of the presence of this layer, na ma-generate ng electric field, thus na generate nga potential barrier. Thus prevent further charge migration. So question kani out from your siguro kung nanay nakabasudaan, it's good, but for some of you pwede nato gamito tatong imagination. What do you think could break this barrier? Tungod kay na form nga depletion region, na ay voltage na na-generate, no? So how could we break that voltage, kibali, or that barrier? Would like to give a guess, no? Okay lang, guess lang good. Like wrong answers. Siguro, no?
Sir, pag yung dog, like, ano daw, sir? Ano mo situation na...
Situation. Kuan. Okay. Um, for example, yan no? Analogy na lang. What kind of resistor? Later, ma-learn na to nga important na component ang resistor. So, it's like this why example na ay strong man diha sa depletion region, di ba? Unsay purpose ng depletion region or unsa iyang capability? Mag-prevent siya og charge migration. So just think na ay strong man diha sa wall, no? Siya ang ga-prevent na magtabok-tabok ang mga charges. Okay, so nice strong man. So how could you beat a strong man? Ano na lang siguro, no? Kung analogy itong gamitin. How could you beat a strong man? Diffusion?
ground, sir, ground. I-ground or something.
Dili. Gamit lang sa analogy na ako ganina, katong strong man. So what do you need to have for you to beat a strong man or strong person? You need a pusil. You need a stronger material. Pusil. Mas kusgan ng pusil kaysa sa strong man. You need a stronger man or stronger person or something stronger material. So if na-generate nga potential na build up, a potential is built up that prevents further charge migration, and this potential is in the form of voltage. So we need a stronger voltage to break that potential. Okay. So I think na-answer dito ganihan ni Dan, no? Although question mark form. Voltage? Yeah, voltage. So we need a sufficient amount of voltage to break the voltage drop or voltage barrier na gi-generate ni depletion region. Okay. Yeah, mo explanation of the energy diagram for the N region shows a lower potential than for the P region. Because mas lower ang potential sa N region, mo explanation ng anong ma-generate ng voltage, no? Because of the difference of energy, right? Now, going back here, if we join together physically an N-type material and P-type material, technically we've created the simplest electronic device there is, the diode. Yan na. The diode is as simply as that, no? the joining of or a joined together na p-type material and n-type material. So that is the diode. So a diode is a semiconductor device with a single p-n junction and metal connections to LEDs. It has the ability to pass current in only one direction. All right. So this kaning image, this already is the diode. Gipagtapad nga p-type and n-type material.
Sir, na question.
Sige. Wyatt, nag-question?
Ay, Dan is
Si Danday. Okay.
mo nang kanang diode, sir. Mo din mo na siya katong one direction lang. Kay mo dili na ipabalik dayon, di ba?
Yes, Dan. Muna ni siya. Muna na siya nga
Okay,
device.
So sir, kung ato ibutang sa analogy nga ang kaning electrons kay tubig, ano siya ang one-way bulb? Analoger sir? Sa analogy.
Malagi nga na I think sufficiently ma-illustrate sa one-way valve ang kuan Kia, no? Ang diode. Yeah, exactly. So kung gamit ana nga kuan, masabtan na nimo ang purpose sa diode if gamit anang analogy.
Yes sir.
Okay. Sige. Actually, naman ko yung diode din ako pangita, but at least kuan ninyo, no? I'm sure some of you already has seen an actual diode before. So, itong pakita ko itong ako, Adeli. Sad. Adela, okay. Uh-huh. Adto mo sa akong camera.
Naka-off sir. Okay na sir.
Okay. Dala, this is the diode. Wala pa na ako nabutang dahil. Sa tong camera din. Dala. Kani siya. Kani siyang diode. Okay. Nasa tunga. Dala. Nakita ninyo?
Yes,
Yes
sir.
sir.
Yes, sir.
Actually, kaning black nga thing, dili na mo ang kuan semiconductor material nasa sulod. Kanang black is just epoxy, casing na siya sa diode nato. Na nasa sulod. If you'd notice, na ay silver nga line diri nga part, diri nga end kani. That's a significant na indicator, and siguro ato nang mga kuan later. Just take note of that nga naa siya line sa diri nga end. Na line dira. Another type of diode is this one. This one. Malag iyang casing is transparent. Transparent nga plastic. That's also a diode. Technically, this is a Zener diode. Mani pinaka-common nga diode, pero may ginato makita. This one, what is this?
LED, sir.
LED.
LED. Yeah, LED. A light-emitting diode. In terms of mechanism, in terms of use, parehara ang use ani sa regular diode. Ang difference lang is siga siya. Lang. Kung mag-work siya, pambala na to nga ga-work siya kay basiga. Yan na. But in terms of circuit design, in terms of mechanism, in terms of p-type and type material, parehara. No? Parehara ang LED. So, pwede na to i-visualize whenever we use diodes sa atong discussion. Pwede lagi ninyo i-visualize as LED. No? So, balik ko sa akong screen. Makita ang screen nga kung na-share.
Yes, sir. Makita.
Yes, sir.
Okay. Sige. So, by the way, no? Mo na iyang main nga characteristic ang nakabutang ron sa slide. It has the ability to pass current in only one direction. And that's it, no? Mo lagi na siya ang diode. There's nothing special further than this. No? Napa ang akong gi-share nga screen? Wala good. Okay. Forward bias, reverse bias. Pikas daw ko nga slide, be. I think mas better na sa Pikas. Yeah, so the diode is a two-terminal device with its electronic symbol as this one. So, muna yung symbol sa atong diode. Okay. So, of course, kung mag-draw ta og circuit diagram, dili man ta mag-draw nga P ug N nga junction dito, but kani nga symbol, no? Arrow facing or pointing to a particular direction. So, para dito malibog, yan na siya. No, para dili kay confusing. Kung asa ang negative nga terminal, maupod na ang horizontal nga part sa arrow sa atong diode. Okay? Kani bitaw, di ba? This is the negative na terminal, this one. So kung asa ang horizontal nga line, or in this case vertical, kung asa ang line nga part sa arrow, muna siya ang negative nga terminal. So ang current magflow siya from positive to negative, no? So for the remainder of the semester, actually magamit ta og conventional current flow, not the electron flow. Okay, kung electron flow, which is more realistic than conventional current, ang electron flow magid is ang electron magflow from negative to positive magid. Pero convention lang man na siya, malag rule of thumb lang gid bitaw. So, dili mag-matter if ang atong convention is ang current mag-flow from positive to negative. So, because of this, because of the ability of the diode to conduct in only one direction, mara siya ing-ani, no? A diode ideally conducts in only one direction. What kind of mechanical device is this aside sa one-way valve na mentioned earlier ni Kia? What other mechanical device that has this characteristic? Capable siya nga mag-produce og short circuit or open circuit sa isa ka given circuit. Unsa nga device na siya? That starts with letter S.
Switch, sir.
Okay, thank you, Nico. So, the diode technically is what we call the electronic switch. Okay? So, ang diode kay electronic switch dahil siya. Unlike the mechanical switch nga atong gamiton sa pag-switch on, switch off sa suga. Mechanical man siya kay kuan man. Kita man ang mag-turn on, turn off sa switch. So, the diode is also, okay, or we could also view the diode as a switch. If masatisfy ang duha ka conditions, and I'll ako na i-reveal unsa ni nga two conditions later, but if masatisfy tong two conditions, no, then the diode will conduct electricity. If only one of those conditions are met, if only one, then the diode will act as a open circuit or off switch. So we have two regions that is of importance. Actually, tulo day gani dapat, no? sa diode. These are the two main regions of interest sa atong diode. We have the conduction region and the non-conduction region. So I think this is the first time that we've seen VI plot or voltage current plot. 'Di ba? Voltage is V, current is I. So mostly kung magamit ta og Cartesian coordinate system, almost all of the time ang kuan gyud so tawag ni ang x-axis is time, no? So not so with this one. So dili time ang horizontal axis, that's the voltage. Ang vertical is the current. So what does this mean? What does that blue line mean? No? That is the conduction region, but what does that mean, man? It means that if the voltage is 0, okay, the current is infinity, no? Or there's a large current flow sa device. So if the diode is working, okay, if it is conducting, ang voltage drop sa diode is ideally 0 volts. And then ang current is well, the largest current possible. Pwede na nato i-model as infinite kaya wala pa man tayo value right now. But it's a large current, no? So meaning voltage is at minimum, current is at maximum. So bali siya if the diode is non-conducting, no? Or if the diode is in the off state, no? Not only is the current 0 when the voltage is or ano lang siguro when the voltage is negative, no? When the voltage is negative, wala current ka mag-flow. So that's another condition of the diode, okay? That's one condition of the second condition of the diode. Aya lang mag-flow ang current if the voltage drop is positive. Okay? If the voltage drop is positive. If the voltage source, is positive. Okay. Namatay din no? The current is infinite, the current is 0. So, once lang duha, no? Inverse. Kanina, naman naman ito ni ganina. Semiconductor material, doping, PN junction, depletion region. Same concept, different slides. The diode has 3 operating conditions. This one. So, tuloy ang operating conditions. No bias, forward bias, and reverse bias. So, kasi difference na nilang tulo. A no bias diode is a diode na naka-store lang somewhere, no? Nabaka sa table or nalabak dito sa cabinet, nala sa container niya. So if the diode is somewhere and not connected to anything, walang no bias, no? Wala lang. That's important because it distinguishes the diode from being not used at all and connected sa isa ka off na circuit. No? So if the diode is connected to a circuit, but let us say the battery is off or the voltage source is off, technically nasa reverse bias ang atong diode. Yan, nasa reverse bias na siya. Wala may current ka mag-flow, no? And connected man siya technically sa circuit. So naka-reverse bias. So the only thing that's left is the forward bias, which is the normal operating condition of the diode. When it's working, it's in the forward bias na mode. No bias, no external voltage, no current is flowing. Only a modest depletion region exists. This is the time na lang siya diha, no? Of course, na depletion region. Even if di siya connected sa circuit, we've known earlier na nag-exist all the time ang depletion region. So the diode is in the reverse bias if the external voltage applied is in the opposite polarity, no? Or dili enough ang voltage. So that's the second condition of nga pangitaon sa diode for it to be in the forward bias mode. If ang applied voltage source is not enough, no? Not enough sa iyahang kadumdum mo atong barrier potential earlier. Katong itong strongman voltage. If dili to masatisfy, no, if dili enough or less than that, kay kung opposite man gud pong nga polarity, let's say if opposite nga polarity, not only is it not enough but it is in the negative nga negative, no, nga polarity. So dili gyud mo on ang diode ana. Either dili enough or negative, dili mo on ang diode. Kano sa lang mag-on ang diode or when will it be in the forward bias nga mode? If the voltage, external voltage applied is enough and the same polarity as the PN type. Ano man, so may mahimo kung the same sila og polarity, what will happen if the positive terminal of the voltage source, nasa bottom nga part, is connected to the positive terminal of the diode, it will allow current to flow. So the same slug direction. So those are the two conditions that we should that should be satisfied for the diode to operate in the forward bias region. Number one, that the external voltage source, this one VD, that the external voltage source should be more, no? More and positive nga polarity ha. Kay pwede man good more pero negative so dili gyapon. The first condition is that the amount of voltage source should be more than the barrier potential of the diode. That's the first condition. The second condition is ang direction sa current. How will we ensure that the direction of the current is correct? If connected ang positive sa battery or sa voltage source to that of the diode. Okay? Kaya kung balin walay current na mag-flow. So this is the actual characteristic curve of the diode or yung plot. Okay? Katong ganina, itong conduction region and non-conduction region, medyo ideal na to siya. This one is more realistic. Base sa graph, at what voltage does the diode start to conduct? The diode start to conduct an infinite amount of current base sa graph. Ma-observe naman nato, no? Sige, I would like to guess. I think, klaro naman sa numbers or sa graph kung unsa nga value ang akong ginapasabot.
0.4, sir.
Sa 0.4. Ang akong pasabot nga diode is kanang blue ha. At 0.4 nag-start nag-conduct, yes. Okay. Thank you, Y. Nag-start na siya conduct at 0.4. Okay. Physical device manoon siya, nagi current mag-conduct at that amount. Ang akong next question is, but at what voltage value, estimated lang niya, do you think, does the diode start to conduct infinite amount of current? Kaya paabot og 0.4, mao pa man iyang pag-rise, no? Mao pa iyang pag-rise. So, maybe, kung ato i-connect siya sa 0.4 nga voltage source, mag-conduct siya current pero gamay pa kaayo. So, who has an answer?
0.8, sir.
0.8. Okay. So, yes. Actually, delete 0.8 yun. Depende sa diode, no?
1.
Kuan.
0.9.
Gamay-gamay lang sa 0.8. 0.7. Wala. Kaning last nga number dire. Sa kana nga kuan, kana nga voltage value, nag-start na og conduct infinitely ang atong diode, no? Ang meaning ana, this is just for illustration purposes, mag differ pa man gyapon ni depende sa diode nga atong napalit, no? But we will use that value 0.7 to model all silicon diodes sa atong mga future examples, future problems, future circuits na i-analyze or i-design. We will use that value 0.7. So 0.7 is the voltage barrier potential of the silicon diode. Okay? Silicon diode 0.7. So germanium, try to, kung lang niya, memorize na nidaan, naka-memorize na dapat ni siya nga value. Kung silicon, 0.7 volts. Kung germanium, 0.3. Okay? Kung mga LED, lahi po na siya mga values, dili na ako necessarily pa-memorize sa inyo hatanan nga voltage drop sa LED kay kada lahi nga color lahi man po nga value. Pero kanilang sa okay, silicon diode and germanium diode. Basta silicon 0.7 gini ihang voltage barrier potential, ang germanium is 0.3. Naman kanina majority minority carriers. Zener region. This is also another important na concept. So, the Zener region aside, mo itong characteristic curve kaganina sa atong diode. Okay? It will only conduct at 0.7. Below 0.7, although it will start to conduct current or electricity, so gamay kay value, no? Only at 0.7 and beyond. Okay? 0.7 and below, even mga negative na voltage drops, bisag 1 volt pa na siya, basta kay negative, dili magkandak anong diode, okay? Dapat positive siya. Not only should it be positive, but it should be more than 0.7. Pero kung below 0.7 and negative, dili ka magkandak. But there is this value that we call VZ, this one, no? Nga pag maabot gani ni nga kuan, pag ma-reach ni siya nga voltage level, depende sa specification sa diode, makita natin na siya sa iyang specs, sa iyang paper, no? Specification sheet. Depende sa value ani. If maabot gani ni nga value VZ, and this is a negative value ha, take note, naman siya sa left side sa Cartesian plane. If the applied voltage source reaches this value VZ, then negative pag yun, the diode will also conduct electricity. And this is what we call the Zener region. No? So long E ni siya ha, Zener. Okay, kaya apelido man eh. Zener region, Zener diode. So much like sa forward bias region, nga nag-conduct siya at 0.7, the diode will also conduct current or electricity at at VZ. No, whatever value is this, dili siya defined pa karon. Yet, if this diode is just a regular diode, the moment mag-conduct siya og current at the Zener region, that's the time nga maguba din siya. No? So, naguba na itong diode pag maabot na ang Zener voltage. Unless it is a Zener diode. So, right now, kato akong ipakita ganiha, those are 3 types of diodes. The first one, the black one, that's the regular silicon diode or regular junction diode. The red one is the light emitting diode or LED. The other one, katong gamay and transparent ihang casing, is a Zener diode. So, the Zener diode operates normally at the Zener region. And if maabot ang Zener region sa Zener diode, dili siya maguba. Okay? Kaya mo man iyahang normal operation sa Zener region. Pero ang regular normal junction diode, kung maabot ka niyang Zener region, maguba siya diretsyo. No? Kung atong i-measure sa oscilloscope, makakita gid siguro tao current ka nag-flow. Pero after 1 second, nag-aso na ang atong diode. No? Buto na siya, naguba. So, these are the important regions sa characteristic curves at diode. The forward bias region, the reverse bias region, and the Zener region. The forward bias voltages, one yung in earlier. The silicon has a 0.7 forward bias voltage, the germanium has 0.3, and the gallium arsenide has 1.2. Unless stated nga germanium siya or gallium arsenide, always assume nga silicon diode. Okay? So, usahay, di na ako ibutang or ibutang asterisk nga given assume a silicon. Because if walay nakabutang otherwise, dili gid siya germanium. Silicon siya. Okay? Temperature effects, as temperature rises, so does the current na mo-flow sa diode. Okay? This is more of a technical na concept sa diode. If we try to compute, actually, no, in actuality, if we try to compute the current that is flowing sa diode, we will not be using Ohm's law. No, we'll not be using Ohm's law. We'll be using a more complicated equation that we call the Shockley equation. And the Shockley equation is dependent sa temperature, meaning the higher the temperature, the more current ka mag-flow sa diode. But because it's very complex to use and kuan na kanang dili gid ka big deal if we use conventional methods and the Shockley equation, we could use diode models, no, appropriate diode models for us to simply use Ohm's law. Pwede na ta magamit og Ohm's law if mag-adapt ta og diode models. And what diode models are these? Before sa diode models, even ang atong diode has static and dynamic resistances. No? Meaning na siya internal resistance. Dili siya purely lang na switch na device. Because ang switch is just one of the models of the diode. No? We could model the diode as a switch. But if we will consider it as an actual active device, actual nonlinear device, nagid siya nag-exist nga masking gamay nga resistance, no? Na siya static and dynamic resistances. So because of the resistances, this is one of the diode equivalent circuits. Okay? And instead of using just an arrow, pwede na to siya taparan og battery and resistance, RAV, or average resistance. In this case, 10 ohms. Because of the internal barrier sa atong diode, this is what I've mentioned earlier, naay capacitance nga mag-build up. So, somehow, naay capacitive nga ability ang diode because of the depletion region. Reverse time, no, this is the time required for the diode to stop conducting once it switch from forward to reverse. So, of course, among the same with all the other normal devices, dili lang kay diode, na siya recovery time. So, dili siya instant na once mo off na diode. We'll dig deeper into the diode specification sheets kung mag-solve na to problems. No? Just take note of this. These are the different diode packaging. No? Lahing itsura sa diode. We could use these devices to test if our diode is working or not. Siguro in one of the lab activities, I'll demonstrate how to check if the diode is working or not using the ohmmeter. Ilang karon. Curve tracer or oscilloscope. Other types of diodes, we have the Zener diode, the light emitting diode, and the diode array. Mo discuss lang ta further sa Zener diode either next meeting or next week. Yeah, I think that's it. Na diyan nag-end ang slide. Okay. Any questions so far? Kung medyo difficult pa i-digest karon, sige lang, that's normal. This is chapter 1 pa man punta sa atong sa atong subject. As we go further along, the more we practice solving diode circuits, and balikan pa nato og basa again ang chapter 1, all the more nga masabtan nato, no? Masabtan nato ang semiconductor materials and how the diode works. If for now, medyo confusing pa ang operation sa diode, don't worry, that's normal. Sure ko saan eh? Maanad lang mo, no? Maanad lang mo pohon sa saan paggamit ang diode. No? Question so far? Na may kan? Na?
Sir, na may question, sir. Baka tong activity bitaw nga naa sa e-learn, sir. Unya, gito 6 p.m.
Sige, ito. Oo, gamay naman to. Makaya naman to ninyo. Basa.
Ay, kan sir, kay si Marco, sir, ba kay naa mo sa hospital karon, sir, ba niya? Na-ask
Okay.
siya og kan, if pwede ba daw niya ma-move gamay ang deadline.
Sige. Pwede lang ako to i-move. Alam mo
Sige.
ka, word pa dato gamay. Pwede lang ako siguro i-move tomorrow. Ang important, basa to ninyo ha. Nakalimutan ko ito. Nag-post ko ito ganyan, no? Cramming more components into integrated circuits.
Yes, sir.
Basagi to ninyo kay important to nga piece of paper, piece of journal na entry for every electronic engineer. So again, mani siya ang diode. Sa kaninga part, kaninga kuan ay silver nga line diri nga part di sila kaya maklaro sa camera. Pero nanay siya silver diri. Meaning, mo ang negative nga part. Timailan na siya. Mo yung negative nga part sa diode kanina ay silver. Kani LED, kung asa daw ang mas taas nga leg, mo to ang negative, no? Yan, sakto man sad mo. Sa pag-manufacture mo na siya, I think mas taas mo yung mas positive. Kalimutan ko. Basta, pagpaliton niya siya sa tindahan, ang LED, na isa ka leg mas longer than the other. And I think mo itong mas positive. Pero kung binuangan mo sa mong classmate, then gitupong niya ang duha, hindi niyo mabalaan ang positive or negative, na susulod, no? Na isa ka plate nga mas baga than the other, mo na siyang negative. Kani mo ni ang Zener diode. Smaller in size compared to the regular silicon diode. And makabalot pa nga Zener ni siya because transparent yung casing. Pero mas dugay ni siya maguba. Kaya pwede man siya reversible, no? Pwede siya magamit sa Zener region. Whereas kani, kung applyan na to og maski negative, di po siguro negative 1, di ba siguro Zener voltage yung negative 1. So let's say for example negative 5, I think guba na ni diretso, no? Di na ko sure kung negative 5 pag yun, but makita lang mo po na sa specification sheet. So the specification sheet is one of the one of the engineer's best friends, Diode, even sa field, no? Even sa field. Much more in designing. Sa specs ginato makita ang atong mga values, atong mga limits. Sometimes mas important pa ang specs kaysa sa atong own nga tools. At least nagi dito sa mga operating conditions. So, dagan kay nga explanation, no? So, pag-explain lang sa kaninga gamay nga device. So, you could review it. To those nga nanay copy sa textbook, ay ebook nga copy, do read it again and again para mas ma-subtan pag yun more on how diodes work. Because in extension, that's how other electronic devices work, man said. It all starts sa how paano na form ilang semiconductor material. So in this class, we'll only be dealing with two types of semiconductor, electronic devices. One is the diode, and the other is transistors. Kana lang. No? So much time lugar for just two devices. Oh, yes. We're trying to build up intuition pa man sa kaninga subject. So, So far, no, di pa man heavy ang akong i-require from you. So, just try to read lang sa your textbook. If kinanglan, pwede mo mag-refer sa mga video sa YouTube, sa itong mga Indian friends. I think mas maka-explain sila clearly sa concepts nga atong gi-discuss karon. Any more questions before we end?